All right. Uh, Part two of creating the wall for our section view is to continue moving upwards. And as in the case of the bedroom walls that we originally created, we have a double top plate and a crown plate. A couple different terms you can use for this, but make sure you close off the top of your wall with a double plate here. Because it's only one wall, this will just sit directly on top of each other. If these walls were interlocked or these pieces were incredibly long, you'd have to make sure that any of the seams where these walls end get overlapped. And again, we saw that in our bedrooms. That shouldn't be new. I've applied some sheet materials, some interior sheet materials. So I did add an additional layer to this document for interior wall surfaces. And you can see that there's drywall, which would be on the wall and then would also be on the ceiling. And you can see how that stuff should be applied. You'd like to have your walls come in after your ceilings so you can tighten up that corner a little bit better. But I can turn those off and hide them for now. And an additional portion that we have is this rafter and joist system. So rafters refer to our roof. So the rafters are actually this pitched surface, which we want to put in first. And then we also can put in a joist system, this portion that comes across the ceiling. In this case, it could also be a second story that walks on top of it. And if there was a room above this first story room that we've already created, you might have additional walls and stuff placed and floor plywood on top of this system. So it could be a usable, livable space, or it could just be open joists that support the ceiling, the hanging of the sheet materials for the ceiling of that first story room. But what I want to talk about is this rafter, which gets notched out and placed on top of, kind of locks itself in around the top double plate of our wall. And there's some things that we need to consider, and this is one area that I'm going to allow you to be a little bit different than maybe the person next to you or even my design, because roofs come in different pitches. There's different reasons for having different degrees of pitch. In this case, I have a chart set up, and just to demonstrate and communicate how roof pitch is executed, we always measure 1 foot of horizontal travel and then compare it to its vertical travel when determining a roof's pitch. Many of the houses that have slate roofs in this community are sitting on 12-12 pitch. Slate roofs typically have a steeper roof. They don't bind together. It's just a natural material lapped over top of itself. So having a steeper pitch can help transport water down more efficiently and ensure that there's less likelihood of leakage. When we went to asphalt shingles, we saw our roof pitches often fall. In many cases, 9 and down to probably close to 312 pitch. So you're seeing a much flatter roof. Just some changes that we saw as materials have changed. If you get down in these lower, flatter roofs, you will get to a point where you can no longer use standard asphalt shingles or slate tiles, and you'll have to go with some other low-pitch roofing material, like a rubber roof that can be sealed and be watertight, even with water running very, very slowly off of your roof's surface. You don't want wind blowing rain back up under your shingles or under your slate tiles, which is why pitch can be important. Pitch can also be very important in the case of inclement weather, snow, ice, stuff that can be falling on top of your structure, and you might want to help that transport its way to the ground. So a flatter roof is not so good at getting snow to fall off. A higher pitched roof, in the case of slate, is more likely to slide off the roof surface more quickly and easily. In either case, the assembly of these roof systems and the application of shingles is a whole lot easier when a roof is probably 5 to 8 pitch, where you're now able to actually start walking on it. You're not going to be able to walk on a 12-12 pitched roof. In either case, you need to be able to communicate what roof pitch you went with, because I'm going to take a measurement of it, and it should fall directly on top of one of these numbers. A 12-12 pitch roof, if its rise and run is equal, you are looking at a 45-degree angle, and that roof line is at 45 degrees. You can calculate these roof pitches in degrees, but it's not a very efficient practice when all we're looking for is to measure over 12 inches and then up a standard distance, and then we set our rafters to it. In this case, I can pick any edge along my rafter, and if I measure in the horizontal 12 inches and drop a line, and then measure vertically up to where it touches, you'll be able to, or should be able to, find your roof's pitch. And I'm wondering if I messed something up here. Let me take another measurement. I'm seeing 10 1/16 inch. I thought I had a 10 over 12 pitch to my roof, and apparently I'm slightly off, but looks like I'm very close. I'm not sure if it's just a measurement I'm currently taking or if I made some other mistake. Your goal is to get your rafter oriented on the proper angle, and that's a quick and easy thing to do if you can measure over 12 and measure up 10 and then create your rafter on that slope. So I might be a 16th off. I spend a little more time looking at it later. But what happens here is then we want to come down and cut out or cut vertically in enough to get me this nice overlapping joint. So once I have my rafter in place, I'm going to actually exit that object, and I'll show you by pulling one of these apart real quick. If you're inside of this group and you're trying to draw a line vertically, it often doesn't snap very well. So one thing that I found, a little trick that I've been using, is if I exit the group, I'm now able to draw a perfectly vertical line. And in this case, I know the height of that line is whatever the thickness of those two top plate pieces are, which are 1.5 inches. So I want to come up 3 inches. And depending on the pitch of your roof, the distance to this next edge will vary, but we'll come straight across in the green direction in this case and snap off a line. Now, none of this was created inside my object, but I now have guides that I can use when cutting this notch. And so I can trace over it and then hopefully select and push-pull that piece away. So I just wanted to show you that quickly. I'm going to back out and snap my stuff back where it belongs. But that's a quick way in which I was able to notch that board out. The ends of these boards will also be cut vertically and horizontally. I tried to leave this at a distance to where we have a full fascia board. Different lengths you can cut this to, but in this case I'm going to go with if I go with a full 5.5 inches here, that gives me a full piece of construction material that can go over the face of this. And then we can put soffitting below this, which is what allows ventilation to get in and out of your roof system. Most new houses have open soffitting, so that way hot air and cool air can exchange through the rafters or this rafter space, and you get this ability for the house to breathe a little bit and for ventilation to take place. So you will often put a ventilated material across the bottom edge of that portion of the structure, so that way you can have ventilation taking place. Some little bit of information. Once that is in place, you can go about applying the joist system like you did on the first floor system. The only thing you need to note is that depending on the roof pitch, you will have to knock off a corner of these joists. So I created these joists separately from the original joists, which are down here. This is a copy, and then I made them unique before I copied them across the top. They all have the same angle cut to them, and they all get butted up against or joined up against the adjacent rafter. So the rafters will also be attached to the joists, so that way everything kind of locks itself together, and we create this solid system in which to occupy. All right, so those are some of the pieces that I went through. I did apply some layers for this stuff or I continued to apply these to the appropriate layers. Get this out of here. My interior wall surfaces, you can create those. I also put some carpeting down, some additional stuff on the inside of the structure, but what I'm after is that this framing gets laid out properly, and then you can start to come back and apply, like we did the sheet materials. I just changed the color. These are just a group of, in this case, 3/4, I think I went 3/4 inch for all the sheet materials, even though drywall is technically thinner than that, 1/2 inch or 5/8 inch drywall usually. But again, we can see that sheet materials are being applied to the structure as well. Maintain your layers. Make sure you get your framing placed in, as I just talked about. One thing I didn't mention is the size of the framing here. These are 2x8s. The joists and the rafters are all 2x8s that I've been using. The wall it's sitting on top of are 2x6s. Just the materials that I chose to use for you in this example.